Hi class, and welcome to a new lesson. This lesson is going to be the first one that starts the second half of chapter 5. You just got done doing a test on the first half of chapter 5, so now this starts another section. In the first half of chapter 5, we did a lot of different properties with monomial and polynomial expressions. On this second half of chapter 5, we're going to build off that. A lot of what we're going to be doing, however, deals with radicals, which is something that you haven't gotten to yet in the first half of chapter 5. So this section 5.5, we're talking about simplifying radicals. So for this first one, we're just going to get us warmed up to simplifying radicals. These ones I'm sure are all pretty obvious, such as you guys know what the square root of 25 is. For number 1, it is 5. And then this negative sign, it means it's negative 1 times the square root of 25. So it's a negative 1 times 5. So it is just a negative 5. So for number 2, the square root of 49, everyone knows it's 7. But it's plus or minus 7 because it's plus or minus the square root of 49. So this is our answer for number 2. For number 3, the square root of a negative 16. Up until this point, you guys have not known how to simplify this. So what we're going to put here is it is a non-real answer. You cannot say it is 4 because 4 times 4 is not a negative 16, and a negative 4 times a negative 4 is not a negative 16. So there's no such thing as taking the square root of a negative number and getting a real answer. It is a non-real answer. I will touch more on this, in fact a lot more on this, in about 3 or 4 more video lessons. So this is what I want you to put for now. It's a non-real answer. Eventually we are going to be able to answer problem number 3 in a special type of way. However, it's non-real. So make sure you write that down for your answers whenever you take the square root of a negative number. Alright, for number 4, we probably don't have this one memorized, but if you put the square root of 529 into your calculator, I'm sure everyone knows how to do that. I will just show you once. It's the second squared button, x squared. So you press second x squared, which is the square root button. So now that you know where that is, all you have to do is put in the number 529, and your calculator spits out the answer as being 23. So the square root of 529 over 225 is 23 over the square root of 2025, is 45. 23 45ths, and then obviously this negative 1 is on the outside, so it's a negative 23 45ths. There's our answer for number 4. And the square root of 0.0625, this one you could also put in your calculator. The square root of 0.0625 is 0.25. So you can put down 1/4 or 0.25. Either one are fine with me, but it's plus or minus that 0.25. So hopefully those are pretty obvious. You can do those in your head, or if you need to, you can use your calculator. Alright, number 6, we get on to a little bit more of a difficult problem. And I think it's something that you guys have been introduced to before, but we're going to be doing more operations with these coming up in this lesson. So the square root of 98. You guys know what the square root of 100 is. The square root of 100 is 10. So now this square root of 98, it's pretty close to 10. However, it's not exactly 10. We can put it into our calculator and see the square root of 98 is approximately 9.899494937. So what this lesson is on here, class, is I don't want to write down this big, disgusting, long answer. Okay, that's messy. It doesn't look very clean. So when that's the case, we're going to simplify these radicals into something that is not irrational, but rational. Just a reminder, a rational number is a number that goes on forever and ever and ever in decimal form. It has no repeating pattern. It just, any number can pop up at any time, and there's no way of predicting that next decimal number. That's irrational. A rational number, however, is something that does come to an end. So I want to simplify this square root of 98. And the way I do it, and I think teachers teach it in different ways, but I just talk about breaking this up into two different factors of 98. And I always want to find the highest squared number that can go into 98. We can always take the square root of a perfect square. So when we talk about 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 8 squared, 64, then 81, 100, 121, 144. You should be thinking of these numbers right now as factors to see if they can go into these numbers. Because if they can, I know that I could take the square root of all of these numbers. So with that being the case, what is the highest squared number that can go into 98? Hopefully you see that 49 can go into 98. 49 times 2 is 98. So I'm going to say that 98 is the same thing as taking the square root of 2 multiplied by 49. Isn't 2 times 49 still 98? So I haven't changed anything. All I've done is change it up into its factors. And now I can take the square root of 49. I know what that is. The square root of 49 is 7. So I can take this 49 outside the radical. This 2, however, has to stay inside because I don't know what the square root of 2 is. So I just leave it simplified as 7. This 7 square root of 2 just means 7 multiplied by the square root of 2, but you're always going to see it as 7 square root 2. You're not going to see these parentheses that tell you that it's going to be multiplying. You can put those in there, but you're never going to see it that way. You could also read it like this, 7 times the square root of 2, but once again, you never see it look like that. It's always written just like this. What's wonderful about these ones is that you can check your work on every single one of these. The square root of 98 is 0.9899494937. And what we did, class, is we just simplified the square root of 98 to be 7 square root 2. We didn't change anything. We should still get the same answer when we do this and when we do this. 7 times the square root of 2, let me prove my point. 7 multiplied by the square root of 2. I will bet you $5,000. I'll bet you $10,000. I'll bet you $1 million that we're going to get 9.899494937. On your marks, get set, go. 9.899494937. You guys just owe me $1 million. As you can see, you can check your work on every last one of these. Moving on to number 7. The square root of 300. Isn't that the same thing as 100 multiplied by 3? If that's the case, this 100 comes outside the radical to make it a 10, and the square root of 3 stays inside. The square root of 300 isn't simplified. 10 square root 3, this is our answer. This is simplified. So why don't you guys pause the video and try number 8 on your own. All right, looking at number 8. This one was slightly tricky. 3 times the square root of 125 is 3 times the square root of 125 is the same thing as 25 multiplied by 5. 25 is the highest squared number that goes into 125. So if that's the case, this 25 can come outside the radical. So now you have 3 times the square root of 25, which is 5, and that number times the square root of 5. So 3 times 5 times the square root of 5. And now class, let's not leave it like this. Let's simplify this part right here. What's 3 times 5? It is obviously 15 square root 5. If you're ever unsure of yourself, whether or not you did it right, once again, you could always check your work in your calculator. 3 times the square root of 125. What is that? 3 times the square root of 125 is this number, 33.54, so on and so forth. And I'm saying, we are saying rather, that 15 square root 5 is the exact same thing. Are we right in that? 15 times the square root of 5. We know with 100% certainty that we did it right if we got 33.54. 33.54. So as you can see, it doesn't take long to check your work with these. I'm not saying you have to do that, especially when you do some Excel math. It might be a little bit cumbersome to check your work. But if you're doing a test question and you're doing these problems in a test, I think it would be silly not to check your work because it takes all of a matter of 10 seconds to do it in your calculator. All right, number 9. What is the highest squared number that goes into 128? Hopefully you think that it is 2 multiplied by 64. 2 times 64 is 128. So this 64 I can take outside the radical because I know what the square root is. It is 8. So now it's 2 times 8 square root 2. And 2 times 8 is 16. So I have 16 multiplied by the square root of 2. That is my answer for number 9. All right, number 10, 11, 12, 13, 14. I want you to listen very, very closely to my words, okay? Listen very closely in 3, 2, 1. The coefficients, you multiply or divide them. The radicals, you multiply and divide them. You do not, I repeat, you do not multiply numbers, you do not multiply coefficients by radicals, and you do not multiply radicals by coefficients. The way I kind of word it sometimes is that the coefficients are in their own world. You can only multiply them by each other. The radicals are in their own world. You can only multiply them by each other. You cannot cross over into the other person's world. Okay, you have to stay amongst your own kind. So radicals have to be multiplied by radicals. Coefficients have to be multiplied by coefficients. We'll go over and do number 10 first. These are kind of like saying 1 square root 3 and 1 square root 24. You're multiplying them by each other. Let's first simplify this, because we know that 24 is the same thing as 6 times 4. So this square root of 3, we're just going to keep it that way. I'm going to write it a little bit lower here. The square root of 3 is going to be multiplied by, this 4 comes outside as 2 square root 6. So now, class, here's the time where my radicals are simplified as far as they'll go. So now I'm going to multiply. The coefficients are multiplied by each other. So 1 is going to be multiplied by 2. And now the radicals are going to be multiplied by each other. You only multiply and divide with your own kind. Okay? So square root 3 times square root 6 is square root 18. All right. Now once we have this, if we can simplify, we do so again. So I ask you, can you simplify the square root of 18? And you say, absolutely. It is the same thing as 9 multiplied by 2. And you still have this 2 as a coefficient on the outside. So this 9 can come outside as a 3, and I hope I can do this all in one step. If I have a 3 right here, 3 times the 2 is 6. 6, and then this square root 2 is left underneath the radical. So my answer for all of this here is 6 square root 2. On these problems, do you think you could check your work in your calculator? Absolutely you can. Let me show you how to do that. I encourage it. It's not cheating, it is being smart. So please do that if you would like to make sure that you get the right answer. Square root 3 times square root 24. Square root, oopsie, that was dumb. Square root 3 times square root 24. That answer is 8.485. 8.485. And when we simplified it, we said that 6 square root 2 is the exact same number. 6 times the square root of 2. That number is, hopefully it's 8.485 if we did it correctly. And the answer is, bam, 8.485. So we know with 100% certainty that we did it right, and it's a wonderful feeling. All right, number 11. We're getting trickier with each problem we go. So let's simplify as far as we possibly can first. So we're going to simplify this 8 to be 4 times 2. And then when we take the square root of 4, we get a 2 on the outside. 2 multiplied by this 5 is 10. So 10 square root 2, that's what this becomes. That 5 square root 8 becomes 10 square root 2. And now we have this one. This is the same thing. 48 is the same thing as 16 times 3, I believe. Is that correct, class? Looking at my notes here. Yep, 16 times 3. So we have 16 multiplied by 3. The square root of 16 is 4. And then when I multiply it by this 4, I get 16 square root 3. So I'm multiplying 10 square root 2 times 16 square root 3. I'm going to multiply the coefficients by each other. 10 times 16 is 160. And I'm going to multiply the square root of 2 by the square root of 3 to get the square root of 6. Class, I cannot be clear enough, I don't think, in the fact that you can only multiply coefficients by coefficients, and you can only multiply radicals by radicals. Don't mix up those two, okay? That's very, very important. So we get 160 times the square root of 6. All right, same rules are true when we are dividing. You can only divide coefficients by coefficients, so these ones, and you can only multiply, or divide rather, radicals by radicals. Don't mix up the two, okay? Now with these ones, it might be easier. We've traditionally kind of simplified a radical whenever we could first. When dividing, it might be easier to just divide them right away, such as this. What is the square root of 72 divided by the square root of 6? We can divide 72 by 6 and just keep it underneath the radical. 72 divided by 6, let's quick do that in our calculator. 72 divided by 6 is 12. So what we have here, class, is when we do the square root of 72 divided by 6, I guess technically speaking, what we're doing is putting the same thing, or putting both of these under one big radical and getting 72 sixths, which is the same thing as 4 multiplied by the square root of 12. But if you wanted to think of it as just this way, it is 72 divided by 6, and because they're both underneath the square root sign, we can do that because we're all in the same world. It's underneath that radical sign. So 72 divided by 6 is 12, and make sure that radical sign is still there. All right, and now we're not quite done yet because we could simplify 12 to be 4 times 3, and then this 4 comes outside as a 2, and it has to be multiplied by this 4 because it is 4 times 4 square root 3. So now, because this becomes a 2 out here, this 4 does, 4 times 2 is 8, 8 times the square root of 3. And there is our answer for number 12. 8 times the square root of 3. Let's check our work one time with this one, just so that I could let you know that you can do that on a test question if you'd like to. 4 times the square root of 72 in the numerator. 4 square root of 72. 4 times the square root of 72. You get this answer divided by, what do we divide by? The square root of 6. Divided by the square root of 6. And our answer is 13.856. 13.856. So all of this right here, that equals approximately 13.856. Now we simplified it, so this answer should also equal approximately 13.856 if we did it correctly. 8 times the square root of 3 is 8 times the square root of 3 is, oopsie, sorry about that, 8 times the square root of 3 is 13.856. That's kind of fun, isn't it? Like when it works out just like this, boom, boom. I don't know, I get a kick out of that. So I know with 100% certainty that 8 square root 3 is my right answer. Let's try another one. 13. I can divide my coefficients. 54 divided by 6, that is 9. And I can divide my radicals. The square root of 6 divided by the square root of 2. I keep that square root and I divide the numbers underneath the square roots. 6 divided by 2 is 3. And that's as far as we can go, class. So I circle my answer right here. I cannot simplify the square root of 3, so I can't do any more simplifying. 9 square root of 3 is my answer. All right, why don't you guys try this one on your own? Pause the video and then check your work with mine after you try it on your own. We simplified the integers, or the coefficients rather. 12 fourths is the same thing as 3. We simplify the radical. Square root of 10 divided by square root of 2 is the square root of 5. Can I simplify this any further? No, I cannot, so this is my answer, 3 times the square root of 5. All right, we're going to do another video lesson on adding and subtracting radicals, because that does get a little bit different and it's a little bit more complicated as well. So I hope that multiplying and dividing these radicals made sense to you. Make sure you let me know if you have any questions as well.